Hi everyone, welcome back. Today we're going to be looking at standard 6.ns.c.8, solve real-world and mathematical problems by graphing points in all four quadrants of the coordinate plane. Find distances between points with the same first coordinate or the same second coordinate. Find distance between two points on the coordinate plane that share the same x or y coordinate. So that's going to be the focus of this video. We're going to use absolute value, which is the distance of a number from 0. An absolute value of a number is always positive. So whenever we're calculating distance between two points sharing the same x or y value, there are two strategies that we can use. The first strategy we're going to explore is if we have a coordinate grid, we can plot those points and then count the number of spaces in between them. So find the distance between the points 2, 9 and 8, 9 as shown here on our graph. So they are already plotted, which was step 1. And then step 2 is to count the spaces between the 2 points. So I like to use my frog method to make sure that I'm counting correctly. So that's 1, 2, 3, 4, 5, 6. So the distance between the points 2, 9 and 8, 9 is 6 units. Find the distance between the points 7, 10 and 7, 2. So here, this is our x, this is our y, x and y. So they share the same x value, and that's the reason why, if you notice, they are vertical, unlike the previous example where they share the same y value and they were horizontal. So we can go ahead and count the spaces 1, 2, 3, 4, 5, 6, 7, 8. So the distance between the points 7, 2 and 7, 10 is 8 units. So in addition to counting the spaces on our coordinate plane, we can also use the absolute value of those coordinates to help us calculate the distance. So find the distance between the points -8, 5 and 3, 5. So first, let's go ahead and count the spaces like we did in our previous example. 1, 2, 3, 4, 5, 6, 7, 8. So from -8 to 0, there are 8 spaces. And then 1, 2, 3 for a total of 11 units. Now, since we're sharing the same y value, so this is our x, that's our y, x and y, we can take the absolute value of the x values, so that's the absolute value of -8 and the absolute value of 3, and add those two together. So the absolute value of -8 is 8, and the absolute value of a positive 3 is 3. 8 plus 3 is equal to 11 units, which is the same answer we found when we counted our spaces. We use addition whenever our values are in different quadrants. So here, 3, 5 is in quadrant 1, -8, 5 is in quadrant 2. Okay, so I'm counting the number of spaces from that number to 0, and then I have to count from 0 to the next number. Our next example, find the distance between the points -6, 2 and -6, 10. So again, I could count my spaces, 1, 2, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 2 plus 10 would be equal to 12 units. So now let's go ahead and try the absolute value and see if we get the same answer. So we have here the same x value. So we're going to be taking the absolute value of the y values. So the absolute value of +2 plus the absolute value of -10. Absolute value of 2 is 2. Absolute value of -10 is 10. 2 plus 10 is equal to 12. Now, this is when I have different quadrants, I'm going to be adding them. When they happen to be in the same quadrant, I'm going to subtract. So here's an example where I have both points in the same quadrant, 6, 2, 6, 6. Find the distance between the points 6, 6 and 6, 2. So I can count those spaces, 1, 2, 3, 4. Okay. So unlike when they're in different quadrants where I added, if they're in the same quadrant, I'm going to subtract. And how do we identify if they're in the same quadrant? Well, here we know that quadrant 1, both of our values are going to be positive. So both of them here are positive. So that tells us that they live in quadrant 1. In quadrant 2, our x is negative, whereas our y is positive. Quadrant 3, both of them are negative. Quadrant 4, x is positive and the y is negative. So let's go ahead and take the absolute values. So the absolute value of 6 minus the absolute value of 2. So that's 6 minus 2, which is equal to 4 units, which is the same as when we counted the number of spaces. We won't always have a coordinate grid, so it's really nice to know this formula for those cases. Find the distance between the points 6, 6 and 6, 2. Oh, this should actually be 3, 6 and 10, 6. Okay, as shown in our graph. So here we see that the y values are the same, so we're going to be working with the absolute value of 10 and the absolute value of 3. Now they're in the same quadrant, so I'm going to subtract. If they're in different quadrants, then I would add. So the absolute value of 10 is 10, absolute value of 3 is 3. So the distance here is 7 units. Let's go ahead and count it. 1, 2, 3, 4, 5, 6, 7. Okay. In some examples like this one where we have decimals, it's not so easy to count on the coordinate grid because we find that our numbers are in between values. So this is where the formula really is useful. So here we see that our x values are the same. So we're going to be working with the absolute value of our y values. They're in the same quadrant, so I'm going to subtract. So the absolute value of 7.7 minus the absolute value of 2.6 is equal to 7.7 minus 2.6. Now I can stack these based on my understanding of subtracting decimals. 7 minus 6 is 1. I'm going to bring down that decimal point. 7 minus 2 is 5. So the distance between these 2 points is 5.1 units. Let's try 2 more examples using our formula. So here we see that both of these values are positive. So that tells me that they're both in the same quadrant, which is quadrant 1. Now my x values are the same, so I'm going to use my y values. So the absolute value of 12 minus the absolute value of 6, 12 minus 6 is equal to 6 units. So the distance between these 2 points is equal to 6 units. Now we take a look at this one. So I have a negative and a positive, a negative and a positive. This happens in quadrant 2, where my x is negative and my y is positive. Now they share the same x value, so I'm going to take the difference of the absolute value of my y values. So the absolute value of 9.9 minus the absolute value of 3. And again, we're doing this because distance is always positive. So even if you did it the opposite way and you said the absolute value of 3 minus the absolute value of 9.9, you're doing distance, so you need to ensure that your final answer would need to be positive. Okay, so always remember we're going to list the bigger number first because distance is always positive. So here we have 9.9 minus 3, which is equal to 6.9 units. So the distance between -3, 9.9, and -3, 3 is 6.9 units. Thank you for watching and have a great day.